Hi there, and welcome to this, our second Car Builder Solutions DVD. We finally found time to produce it, and this time it's all about plumbing. Plumbing is a large and important part of building your car, but of course it doesn't just relate to engine cooling. It also relates to fuel, to induction, to brakes, to heating and air conditioning, and even vacuum. And we're going to be dealing with each of these topics in turn. But first, let's just clear up one major area of confusion when it comes to plumbing. We get more questions on this than anything else on the telephone. And the question is, the hose size, is it ID or OD? Inside diameter or outside diameter? And there's one golden rule that will help you sort it out. Everything hard, like copper, aluminium, steel, plastic, and even nylon is all measured on the outside diameter. Anything hard on the outside diameter. And anything soft, like rubber, silicone, flexible ducting, PVC, is all measured on the inside diameter, the ID. Simple. Okay, we're going to start with engine cooling. But remember that all the products that we're going to show you in this film, you can find full details of them either in our catalogue or our online shop. It's pretty unlikely that you'll find an off-the-shelf hose kit for a kit car or a custom or a one-off build. But you can find everything you need from our range of hoses and joiners. There are basically two types of hose available for plumbing the cooling system of a car. Rubber hoses and silicone hoses. Rubber hoses are available in straight lengths of 1 meter or in 90-degree bends, from large sizes like 60mm ID right down to a 10mm ID hose. If you only want a short length of straight hose, it may be more economical for you to buy a 90-degree bend. For this 50mm one, for example, you've got a good 10 inches or 200mm of straight hose on there. You can just cut it off, or you can shorten down a large bend to a small one. The silicone hoses are available with a range of bends, like this 180 for instance, or this 45, or this 135, or even this 90 in black or the blue. All the silicone hose sizes are also available in 1 meter lengths, and some of the smaller sizes are also available in 2 meter lengths. Flexible hoses are available in both rubber and silicone, like this rubber 38mm for instance, in 1 meter length. You can bend it fairly tightly and you can cut however much you need from 1 meter length. We also stock a range of Volcaflex hose in different lengths and internal diameters, which have a metal spring inside to prevent it collapsing, and a straight piece at each end. This one is a 38 by 375, and you can bend it to any angle. Smaller sizes of coolant hose from 8mm to 19mm ID are available off the roll in both rubber and silicone. So if you're plumbing, for instance, a heater, you can have a 5 meter length if you wish. Whatever hose you choose, sooner or later you're going to have to cut it to length, and the easiest and neatest way is using our hose cutters. I'm going to cut this piece of 19mm heater hose. We pull the handles apart to open the blade. We close the blade down by hand on the hose, keep it nice and square, and pressing the blades together, ratchet the blade until it makes a nice clean square cut. You can even cut larger hoses using a similar method. Open the blades as wide as you can. Push the cutter onto the hose and compress the blades together with your left hand while you're ratcheting with your right. Put it on the bench and press down on the blades and keep pressing while you're cutting through the ratchet. Open the blade and take a second cut. And there you go, you're through. Once you've cut your hoses, there's a good chance you'll need to join them together at some stage. And we have a range of products that will allow you to join hoses of the same size or hoses of different sizes. I'm going to show you a few of those products. We can make a straight aluminium joiner in any size from 12mm OD up to 75mm OD and any length. We manufacture these to order and we roll the bead on each one. So if you want to join a 3 inches long or 3 foot long, it's not a problem. We also have a range of joiners with welded T's, 15mm and 8mm T's, so you can have a take-off for a heater. Very simple aluminium joiner. We also have a range of aluminium step joiners. These are all 75mm or 3 inches long. This one goes from 25 to 32, and this one from 38 to 50. We also have a range of silicone stepped hoses. This is a 90-degree bend with a 50 in one end and 38 in the other. And there's a straight joiner with 38 and 32 in black and in blue. We have a range of very simple straight joiners in brass and nylon, just for joining two lengths of the same hose together from 4mm to 19. And we also keep a range of glass reinforced nylon stepped joiners, which you can cut down to whichever size you like. This one has 35mm and then 38 and then 40 and back to 38, so you can cut it at any section. And the same with 90 degree. This one has 10, 12, 19 and 25. And again in T's. This one has 25, 32 and then 16 and 12. Just cut the ends off with a hacksaw. And this is our range of mix and match hose connectors. You can see full details of these in the catalogue. But you've got a selection of T's, 25, 32 and 38mm through, and then in the top of the T you can choose any of the inserts from 8mm to 32, and I'll show you how they go together. For each insert you have an O-ring and a retaining clip. The O-ring just pushes onto the insert pushes into the T, and the retaining clip slides on, holding it all in place. And you can use the same process using the O-rings and the inserts to make a straight joiner with any size at either end, or a 90 degree with any size at either end, or a wide piece with any size in any of the 3 outlets, or even a cross piece with any size in all 4 outlets. And there's a range of moulded nylon Ys from 6mm to 19mm. I'm just going to join this 38mm elbow to this 25mm elbow with a stepped aluminium joiner. Always use a little bit of soapy water on the joiner and in the hose, just makes it go together a bit easier. Slide the joiner in the hose. You can put your Jubilee clip around it if you want to, and then do the other one and slide that on too. A couple of nice clips, and they've got retaining lips as well to stop it pulling apart. It's important that any joiners you use in your plumbing system have beads on them, like these on here. Once your Jubilee clip is tightened, it prevents the hose from pulling off under pressure, so it's a security thing. And use good quality hose clips. These are hose clips from our range, and they have a radiused inside edge so it doesn't cut into the hose. And always position your hose clips midway between the end of the hose and the bead. So you've got a bit of hose sticking out this end, and the bead is a little way back there. And tighten them with a spanner, screwdriver or a socket until they're nice and tight, and always go around and re-tighten them after you've run the engine for a few minutes and got it up to temperature. To make a neat and tidy job of your plumbing, it's often important to know the bend angle and bend radius of a piece of hose or pipe. And this is another area of confusion that we often deal with on the telephone. I'm going to explain it using this piece of ducting and two 38mm short lengths of aluminium tube. I've laid the components out on the bench here, and I've marked two lines that are tangential, that's 90 degrees to the hose and the tube, at the point where the bend of the hose starts and the point where the bend of the hose finishes. There's the aluminium tube, which comes to about there inside the hose, and there this side. So we've got two lines at 90 degrees at the point where the bend starts and where the bend finishes. And I've extended those lines to a point where they cross right here. Now you always measure the radius of a bend from the centre of the hose. So I'm just going to lay my rule on there, and it's round about the centre of the hose, and the radius of that bend is where the two lines cross. So the radius of that bend is around about 110 millimeters. So that bend has a 110 mil radius. And the angle of a bend can be anything from 10 degrees to 90 to 180. And that's measured from the point where the two lines cross, the radius, and it can be anything. And to do that, we can use a protractor. We can slide our protractor underneath the hose in line with the two marks, and we can adjust it until they line up, and we can take a reading off here, which looks about 90 degrees, 89, 90 degrees. So the angle of that bend is 89 degrees and the radius is 110 mil. Of course, it's always best to keep to a minimum the number of joints and potential leaks in your plumbing system. And here's a great little product that will not only reduce the number of joints in your engine bay, but also tidy it up and make a much neater job of your plumbing. It's called a hose former. Here's how it works. They come in a range of sizes and are designed to fit quite tightly over the outside diameter of your hose. For instance, a heater hose. You can slide your heater hose up inside the hose former, and once it's in there, it's a nice tight fit. you can make a very tight 90-degree bend on the hose former without collapsing the hose. Because the spring of the hose former is tight around the hose, it prevents it collapsing, and you can make a nice tight 90 or any angle bend and it will stay there without collapsing. Now, all engines have sensors and switches on them. Sensors for water temperature, oil pressure, oil temperature, turbo boost, speedo pickup, and switches for electric cooling fan or maybe electric water pump. And it's pretty likely that you will need to adapt the sensors to your engine, and there's a complete range of adapters and fittings available that will help you do that. But before you start buying your adapters, the most important thing is to be able to identify the threads on your sensors and switches, and we're going to show you how to do that. There are 3 tools that you need: a digital caliper, a set of TPI gauges, that's threads per inch, and there's a set similar to this one in our tap and die set, and the tapping chart from the back of our catalogue. There are a whole range of threads, both imperial and metric, both parallel and taper threads. So the first thing to do is to measure the diameter of your sender thread. A parallel thread will have the same diameter all the way along its length, but a tapered thread will have a larger diameter at one end and a smaller diameter at the other, and you can measure this with your vernier caliper. A digital caliper will have a button on it that allows you to switch the reading from metric to imperial just with the press of a button. So you should have a pretty good idea from measuring your thread whether it's an imperial or a metric thread. The actual diameter of the thread will always be just a little bit under the nomination of the thread. So this M14 thread actually measures 13.8 diameter. The next step is to measure the thread pitch. Imperial threads are measured in TPI, that's threads per inch, so it may be 18 TPI. Metric threads are measured from the crown of one thread to the crown of the next, so it may be 1 millimeter, 1.25 or 1.5. Choose the thread gauge that exactly matches the profile of the threads on your sender. This one is a metric thread, 1.5 pitch. You can then refer to the chart in the catalogue and you can identify the thread if it's a UNF, a BSF or a metric thread by the pitch of the thread and its diameter. The exceptions to this rule are NPT and BSP, that's National Pipe Taper and British Standard Pipe Taper threads. Those sizes refer to the ID of a tube with that thread on it. But all you should need with BSP and NPT is the pitch, the TPI. Now if you're lucky, your switch or your sender will screw directly into the thread on your engine. But if it doesn't, then you're probably going to need an adapter like these brass ones here. There are hundreds of combinations of male and female threads, and we stock a lot of the common ones, but it could be that your particular combination just isn't available, so we're going to show you how to make one. Okay, let's suppose that the union you're looking for has an M22 male thread and a 1/2 inch hose tail. But you can't find one, but you can find an M22 blanking plug union and a 1/2 inch hose tail with a different thread on it. So we can make the one union out of the 2 of these. To join these 2 together, we're going to use a process called silver soldering. Now, it's not soft soldering that you use on wiring, and it's not welding. It's a process where the 2 surfaces are fused together with a layer of silver which bonds molecularly to the surface of each piece, giving you a very strong joint. This is a rod of silver solder. You can get it from most model shops, and this is silver solder flux, and we're going to make a very thin paste with a little bit of water and a little bit of flux. The silver soldering relies on having two pretty flat surfaces together. It won't gap fill. So we're going to cannibalise this 1/2 inch union by sawing off the thread that we don't want and then filing the surface flat with a file. Now it's critically important that both surfaces are clean, so we're going to use a bit of wet and dry just to clean up the surfaces. Perfect. Now this is a fire brick. It's going to prevent you from burning your bench. So we're going to dip one part in the flux, get it covered and set it on top of the other part, making sure that both surfaces are nicely evenly coated with plenty of flux. Now we're going to warm it up with a butane torch. Get it nice and central. It's important that you don't get the joint too hot. You'll see the flux begin to melt and it will start to flow around the joint, and you can start to feed in a little bit of solder, which again will flow on its own all the way around the joint and all the way through the gap by capillary action. Just keep a gentle flame, warm it all the way around until it's flowed and filled the joint. You can then drop it in a bucket of water, which will clean off the flux, and give it a quick wire brush. And you can use the same process to make up any combination of parts you need. Of course, not all switches and senders are designed to screw directly into your engine. Some need to go elsewhere in your plumbing system, and an inline housing adapter like these could be what you need. These aluminium housings are available for 32mm or 38mm hose, and they already have an M22 thread in them, so if your switch or sender has an M22 male thread, this is all you need. But there's also a range of screw-in inserts, and they come in a range of 6 different threads. These aluminium housings have an M10 thread in them as standard, which we can enlarge and we can take out to any thread you like, and sometimes we can even put an additional thread or 2 in the housing in the sides. This one is fitted with a sender for a water temperature gauge, but this one has a 90-degree hose tail for instance a header tank takeoff, and this one has a blanking plug for instance an air bleed. And in this one we fitted a brass union with an olive fitting that will accept the probe from our adjustable fan switch. Here's a common scenario. The inlet spigot on your fuel tank measures 63mm diameter, and you've got to connect that up to your fuel cap. No problem. Here's a piece of 63mm ultra flexible fuel filler hose. Problem is, the fuel cap measures 57mm diameter. Oh dear. But there's a solution. This is an internal hose reducer. Its inside diameter is 57mm and its outside diameter is 63mm, and there's a little ridge around the top. And this is one of a range that goes right down to 25mm. And the idea is very simple. It just fits inside your 63mm hose. And the little ridge stops it falling right in. And there's your 57mm fuel cap. A perfect fit. But it doesn't end there. Say your fuel cap is 50mm. Well, you can just choose the next step down of the internal hose reducer and put it inside the first one. So now you have a 63mm ID hose that's been reduced right down to 50. And there's your 50mm cap. Perfect fit. Many hoses like this silicone ducting and this flexible fuel hose have a wire spiral running through them, and it's not always easy to cut them nice and neatly. But all you need is a good sharp knife and a good strong pair of wire cutters, and here's how to do it. Now lay your ruler on the hose and rotate the hose until you find a point right next to the wire reinforcing at the dimension you need. And insert your knife blade right next to the wire and make a little cut. Now, keeping the knife tangential to the hose, that's square to the hose, gradually work your way around the hose. You're moving away slowly from the wire. Keep the cut nice and straight. Go slowly, there's no rush. Roll the hose as you cut. And eventually, when you've done a complete turn, the knife blade will be at the same place on the other side of the wire. You can then take your cutters and cut the wire. And any last little bits of hose. And there you have a nice square clean cut. You can always bend that last little bit of wire back into shape to the hose profile. Plumbing your fuel system with push-in fittings and hose clips is pretty simple stuff. You can use textile covered rubber hose for carburetor systems, high pressure rubber hose for fuel injection, and there's even stainless braided fuel hose for a bit of dress up or extra protection. And cutting small rubber hose cleanly is pretty easy with hose cutters. But cutting the stainless braided hose is not quite so easy. You could end up with loads of sharp stainless ends on the hose. Here's a method you can use in your home workshop. The first thing to do is to wrap some masking tape tightly around the hose where you need to cut it. Wrap some cardboard around the hose to protect it and clamp it in your vise with the cutting line as close as you can to the jaws of the vise. And then you can get a metal cutting disc for your angle grinder, you can buy a disc which is just a mil thick, 1mm thick disc, and put it on your angle grinder. And safety gear, glasses and gloves, and just cut through with the grinder. Now it's important that you clean out the hose thoroughly, because there will be some powdered rubber and stainless inside, and you don't need that in your fuel system. Now I'm going to finish it off with one of these aluminium hose finishers. They come in all different sizes and colours, and an inline fuel filter. You can leave the tape on, it's holding all the stainless together. Just put over your hose finisher the right size, and a little lubrication, push in your inline filter, tighten up the hose clip, and a very neat job. And rather than regular Jubilee type hose clips, a better option for these small hose sizes is the fuel hose clips. These are available in stainless or zinc, but they have a band that goes round the whole of the hose 360 degrees all the way around, which means that it doesn't pinch the hose, and it gives you a more secure and pressure tight joint. And when it comes to fixing your fuel pipe to your chassis, a great option is rubber lined P-clips. These are again available in zinc and stainless, and you can just put them around your hose. They won't chafe, they won't rub, they'll keep it secure, and you can rivet it or screw it to your chassis. Engine cooling design is a huge subject that's impossible to cover in just a short video. But there's one area of confusion to clear up before we move on. What's the difference between a header tank and an expansion tank? Many people ask us for a header tank when what they really need is an expansion tank, and vice versa, and they really are two very different components. The big difference between these two components is a header tank is pressurized. It's part of the cooling system, and it runs at the same water pressure as the rest of the system. The expansion tank is not pressurized. It works at atmospheric pressure, and although it is part of the cooling system, it's outside of the pressurized part. The header tank must be at the highest point of the cooling system. Its main function is to always ensure that there's adequate water to flow around the cooling system. Its other function is to collect air from all the high points in the system and bleed them back to the tank. On this header tank there are 3 hose connections. The big one at the bottom here, 15mm, this is the one that feeds the cooling system and makes sure it's always got water. This one goes down to a T-piece, which is connected into your bottom hose just before the water pump. This 6mm hose tail here has got a piece of hose on it which would go, for instance, to the top of your radiator to collect air from the top of the radiator and bleed it back into the tank. And this one, which is between the 2 seals of the radiator cap, this is the one that goes to the expansion tank. So why do you need a header tank in an engine cooling system? Well, all engines will expand and contract as they get hot and cold, and the water that's displaced in this expansion and contraction has got to go somewhere. So a header tank collects the expanded water as the engine gets hot, and as the engine cools down, it'll take it back into the engine, so you've always got the optimum amount of coolant in your engine. Not all engines expand and contract very much, so on a smaller, maybe a bike engine, you may get away with just a radiator cap in your top hose, going off to an overflow or an expansion tank. So where does the expansion tank come in, and do you always need one? Well, not necessarily. You could try an experiment when you've built your car try and fill up the header tank just half full, and if the water expands just another inch or two up the header tank, that's fine, that's probably all you need. But if you've got a lot of expansion in a larger engine, then the expansion tank could be the answer. But to understand how an expansion tank works, we've first got to understand how a radiator cap works. This is a standard 13-pound radiator cap, and there's two rubber seals on here a specific distance apart. And the matching neck on the header tank also has two sealing surfaces the same distance apart. And this hose outlet is located between the two seals in the neck. Now, located between these two seals on the cap is a spring, and this spring is set to 13-pound pressure of your cooling system. So if your cooling system pressure comes up beyond 13-pound pressure, this seal is pushed away against the spring, allowing the fluid to go past the seal into the neck and out of that aluminium hose union. And that hose union is connected via a piece of 8mm rubber pipe to the expansion tank lid. Here it is. Now this lid has a tiny hole in it to vent the expansion tank, making the pressure the same as everything else outside the car system. But there's a pipe linking the lid and the hose that goes right down to the bottom of the expansion tank. And you should always have just enough water in the bottom of the expansion tank, maybe an inch, to cover the bottom of the hose. So we run our engine, the coolant gets hot, the engine gets hot, and the coolant expands. It expands beyond 13 pounds pressure, which is the pressure of the cooling system, and it blows past the first seal in the radiator cap, through the overflow pipe, into the expansion tank, and adds water to the expansion tank, maybe up to 3/4 full. When the engine cools, the water from the expansion tank is drawn back through the pipe, back through the filler neck, back through the radiator cap, and back into the header tank. So how does that work? Here's the clever part of a radiator cap design. This little brass cap on the end of the first seal is actually a sprung-loaded valve, and as it sits naturally, it seals against the bottom seal of the cap under pressure. And as we've said before, the water will compress the first seal and escape past into the expansion tank. But as the engine cools, it tries to create a vacuum inside the engine, trying to draw the water back in. And this little sprung valve will open, allowing the water from the expansion tank to come back into the engine. Clever stuff. Header tanks come in all shapes and sizes, but they all do pretty much the same job. This one's a base mounted horizontal tank, which you can sit, for instance, on top of a pedal box or a footwell. This is the same type of horizontal tank, but this one has a rear mount, so you can mount it on a bulkhead. And here's a vertical one. This also has a rear mount that you can mount on a bulkhead. But they've all got the same inlets and outlets. Okay, time to talk a little bit about plumbing your brakes. Most of the pipe runs on your car will be either copper or copper nickel, and the most popular size is 3/16. And once again, you'll need to identify the threads of your master cylinder and your calipers and your slave cylinders, and it will make sense to stick to either imperial or metric throughout your system. But if you've got a mixture of metric and imperial components, you can use metric and imperial fittings, it doesn't really matter. Now I'm going to show you how to make single and double flares on copper and copper nickel brake pipe using two of the tools that are available from our catalogue. This is a handheld flaring tool which is very useful for making flares on pipes that are still on the car. And this is a heavier duty vice mounted tool, and this one will also do steel and stainless brake pipes. The handheld tool is supplied with a die strip with 6 different dies for different pipe sizes. First thing to do is to just get a hacksaw and cut these all off into individual dies like this one. And then the next thing you need to work out is whether you need a single or a double flare on the end of your brake pipe. This union would accept a single flare like a ball end, and this one would need a female flare to go over the convex end of the union. First thing to do is to prepare the pipe. Now I'm going to cut it to length with this little tube cutter which comes free with one of the flaring tools, and I'm going to deburr it with a countersunk deburrer. Now I'm using 8mm copper here just to make it easier for you to see, but the same technique and methods apply to all sizes, including the 3/16 brake pipe. I'm going to put the brake pipe cutter on, tighten it up, and start to rotate it around the tube. Tighten it again, keep rotating, tighten a bit more, a bit more, and gradually the sharp disc will cut its way through the pipe. There we go, and we just need to deburr the end. Make sure you don't get any swarf inside the pipe. You can give it a good blow through if you need to. There we go, nice and clean and ready for the next step. I've put this handheld tool in the vise on the bench just so that it's easier for you to see what's going on. Now if you open up the handles of the tool, you'll see that these 2 wheels in the tool here rotate, so you can select the pair of jaws that's going to match the tube size you want to flare. And we're going to select the 5/16 size, which is 8mm. Now each of these dies has a little cutout in the side, which is 1 millimetre or 2 below the level of the side of the die. And this is what we use to set the height of the tube in the jaws of the machine. Just hold the die across the top of the machine and put the tube in until it touches the cutout, and then tighten the jaws by squeezing the handles together. Now by loosening this nut and rotating the bolt underneath, which is actually an eccentric cam, you can adjust the closing pressure of the jaws so you get a nice tight grip on your pipe without distorting it too much. Now if you're flaring a pipe on your car, don't forget to put the union on first before you make the flare. Next thing to do is to lubricate the die, just a drop of oil and the thread of the anvil on the machine, and then we can put the die upside down into the end of the copper pipe. We can swing over the anvil until it locates on the other pillar. Then we wind down the thread until it just tightens up, and then apply steady turning pressure You're making the flare. Keep going until it goes too tight to turn easily. You can back it off, swing the anvil out of the way and remove the die. But be very careful with the smaller sizes. They're made of very hard material and are quite fragile. And there you have a single flare, the male ball type. Now if it's a double flare you need, that's a female concave flare. Just put the pipe back in the jaws where it was, clamp it up again, swing over your anvil and again wind down the cone till it touches the pipe. Keep going. Until it gets too tight to turn easily. Back it off. And there is your female flare. Now I've mounted the heavy duty machine in the vise on the bench and I'm going to show you how this one works. This one has different die blocks for making the flares and different clamping blocks depending on the pipe size. And this time I'm actually going to use 3/16 copper brake pipe. But the same applies. Make sure your end is cut nice and square and is deburred and is clean. There's no swarf inside the tube. Now we lay the bottom half of the clamping die in the tool and then we lay the copper tube in the clamping die, making sure that the end is flush with the end of the die. And then we put the top half of the clamping die on, swing around the clamping anvil and clamp it tight. Now these flaring dies have a label on them. This one is labelled Op1, which is your single flare, the ball end, and this one is labelled Op2, which is the second operation, which forms a female flare after this one. So we're going to drop this in the machine in the groove. And we're going to do Op1 first. We line up the die for Op1 with the hole in the tube and we gently manoeuvre it into place, and then we pull the lever on the machine until it's gone its full travel. Remove the die. Undo the clamp, and there we have the male ball end flare. Now to turn this into a female flare, we put it back in the tool, put the clamping jaw back on, tighten it up. We put the die in, this time it's Op2, we make sure it's lined up with the hole in the tube and we give it a good squeeze on the handle. Take it out. And there we have the female flare. When it comes to bending, it is quite possible to make reasonable bends with your hands of soft copper tube. You can just form it gently around your thumb, gentle bend. If you don't go too tightly, it looks quite neat. But if you want to make neater, tighter bends, there are a couple of tools available that will help you do that. This one will bend 1/8, 3/16 and quarter tube, and this one is specifically just for 3/16 brake pipe. Let's see how they work. Just set your copper tube in the correct size guide and then roll the two jaws together, forming the copper into a bend. Go as far as you like. You can take another bite if you want to get 180. And there you have a pretty neat bend. Or on this one, just clamp it around your tube, hold it tight, and then bend your tube in the jaws of the bender. Right, on to heating, air conditioning and ventilation. Now, it's a legal requirement in the UK for every car with a windscreen to have at least demist function. So if you're not bothered about cockpit heating, or you want to keep the weight down for, say, a road track car, then these little electric demisters may be all you need. Two of these, one in front of the driver, one in front of the passenger, mounted at the base of the windscreen, either on the top of the dash or beneath the dash with this little vent panel sticking through, will give you just about adequate demist to comply with the current regulations. These are not really powerful enough to make a significant difference to the heating of your car, but even so, a pair of these draws a hefty 28 amps from your battery. So this is the reason why electric heating in a car is not really a practical proposition. So if you're looking for powerful heating and demist for your car, then a hot water powered system that is fed from your engine is the way to go, and there are several options. This one here, for example, is a very compact unit. It has an aluminium heat exchanger, and it puts out the equivalent of over 5 kilowatts of heat. It's a 3-speed fan on here, a double squirrel cage, and it comes with the wiring and a switch, and it also comes with a plenum that fits over the front, and you can cut these outlets open so you can have demist, face vents or footwell vents, whichever you choose. Just open up the outlets by sawing the ends off with a hacksaw. The inlet and outlet of the heat exchanger, or the matrix, end with a piece of 15mm copper with a bead on it. So you can use standard 15mm heater hose, but we would always recommend that for any heater hose connection inside the cockpit of the car, you double hose clip the joint. You wouldn't want to be in the cockpit of a car if the heater hose comes off. You can feed the heater hoses through a grommet in a bulkhead into your engine bay, or you could use one of these bulkhead connectors. These are available straight like this one, or with 90 degrees on one side. Your engine may already have inlet and outlet ports for your heater feed and return, in which case just use those. But if it doesn't, you have to take a feed from the top hose and a return back into the bottom hose, and again you can use a T-piece with a 15mm T on it. You'll notice for this demonstration that we haven't used hose clips on every joint. Now, depending on where your heater is installed in relation to its height to the engine, you may need to install a little bleed valve to get the air out of the heater system. This one's very compact and it's got a little brass thumb screw on it. You may wish to install a valve that can control the flow of hot water through your heater from full flow to nothing. This is a cable operated one that has a dash mounted sliding control. Or there's this very simple rotary one which mounts to the back of your dash. The control shaft pokes through the front of your dash and you just put a rotary knob on the front. And when it comes to distributing the air around the cockpit of your car, there are all sorts of valves and vents and ducting and plenums available which will help you direct the air exactly where you need it. For instance, I've connected a piece of lightweight 63mm ducting onto one of the larger outlets of the plenum, and I've taken it to one of these 100mm vents which rotates and opens and closes. This can be a face vent or a demist vent or a footwell vent. Or I've connected a piece of 38mm ducting to one of the smaller outlets in this plenum, and I can use one of these little under dash plenums, and you bond this to the underside of your dash just at the base of the windscreen. You can put the ducting on it, and then you can cut some holes in the top of your dash and let in these little tiny letterbox vents in the top, so that's all you see. Here's a three-way butterfly valve. These come in several different sizes, and they can be cable operated with this little lever on the top here. You've got your inlet, and inside there's a butterfly which moves from left to right with this little lever, so you can direct your air out of either of these two outlets or share it between them. And here's a lovely little face vent. It's got a 40mm inlet, and inside is a butterfly valve which is controlled by this little wheel, so you can turn it on and off, the airflow. And the vent itself both rocks this way, and inside there are some more vanes that are directed left and right by this little lever on the top, so you can point the air very accurately where you want it, either on your face or on the screen. So you can point the air very accurately where you want it, on your face or on the side window or on your hands. Here's quite a large underdash plenum. This one's about 500mm long, about 2 feet, and it's got a 40mm inlet which is offset, so depending on how much room you've got available under your dash, you can have it this side or on the passenger side if you want to. So if your dash top is fairly flat, or even with a slight gentle curve, you can bond this under your dash at the base of the windscreen, and then cut your holes in the top of your dash, 3 or maybe 4 of them for the little vents, and space them along wherever you need them. Of course, all of these components can be used not only for heating but also for air conditioning. So let's talk a little bit about that. An air conditioning system has 4 basic major components. This is the evaporator, which goes inside the car under the dash, usually above the passenger's knees somewhere. This one has 2 matrices inside, the air conditioning coolant matrix. It's also got a heater matrix inside as well. It's got a 3-speed fan and a built-in plenum with 4 outlets. This is the condensing radiator. This is mounted usually in front of the conventional radiator, and you can put a fan on this one. You'll probably get a 10-inch fan on here as well. This is the compressor. This has got to be mounted to the engine, and it's driven from the crankshaft pulley. You may or you may not have enough grooves on your crankshaft pulley to drive an extra device like a compressor. So you may have to convert the crankshaft pulley for an extra drive belt. And this is the receiver dryer. This keeps the refrigerant clean and filtered, and the trinary switch protects all the other components with an overpressure and underpressure sensor which switches off everything should you lose refrigerant or system pressure. These 4 components are all connected together using 3 different sizes of refrigerant hose, and the unions for those hoses are all crimp unions. One end has got a thread which screws onto each particular unit, and the other end has got a crimp ferrule. The hose pushes into it, and you can take this to a local lorry hydraulic specialist which will have a crimping tool, and they'll crimp the hoses. Air conditioning and heating systems are at their most efficient when they're recycling the cockpit air, but it makes sense to have a small proportion of clean fresh air coming into the vehicle, and you can do this quite easily just by fixing a piece of 40mm ducting to the back of the air conditioning, say just between the squirrel cage fans there with a tie wrap or something, and run it out through to say a wheel arch or somewhere outside of the car where it can pick up clean fresh air. These compressors are considered to be universal compressors. They're plenty powerful enough for a large 4-seat saloon, and they have an easy mounting option with 4 holes on the front and back on 2 flanges. This one is a poly V belt drive, but they're also available with a double A groove belt drive like this one. And you can have the outlets on the side at the back of the compressor, or you can have them on the end at the back, whichever is most convenient for your hose runs. One of the most difficult aspects of installing air conditioning into a car is mounting the compressor, so it may be worth checking that your engine wasn't once used in a vehicle with air conditioning. If it was, then it's more likely that you'll be able to buy the brackets and the compressor specifically for your engine, save you a lot of problems. But if you're mounting one of these types of compressors, always make sure that it's dead in line with the crankshaft pulley, and make sure that you build in some sort of belt tensioning adjustment. This one has 2 A grooves on it, which means that you can maybe replace your alternator with this compressor, drive it with a single short belt from the crank pulley, and then drive your alternator, which you can mount somewhere else, from the second groove. Condensing radiators come in all shapes and sizes, and you need to mount this in front of your conventional radiator with maybe an inch gap between. A fan on the front will assist. If you're standing in traffic, you're not getting any airflow through there, so a fan will cut in and you can still have air con. Here's the unions for connecting up to the hoses. The dryer can be mounted pretty much anywhere, but it's usually in the engine bay on a bulkhead. And the 2 charging ports also need to be readily accessible, so you can charge and recharge and check your system easily. And don't forget, there's an awful lot more information about our heating and air conditioning systems in our catalogue, which you can download from our website. And finally, a quick word about servos and vacuum. If you're going to fit servos to your car, you need to choose a thick wall hose that won't collapse under high vacuum like this one. But if you're plumbing, say, a mid-engined car with the servo at the front and the engine at the back, it's a good idea to do the major run in a piece of 15mm copper and then just connect it at both ends with a short piece of rubber vacuum hose. And don't forget your non-return valve. These are available in all sizes in aluminium and nylon, and you can adapt the sizes up and down to match the hose and the servo at each end. Well folks, that's about it for this film. Thanks for watching. We hope you've enjoyed it and hope you've maybe even learned something from it. And who knows, we may be tempted to do another one sometime in the future. Maybe on the build of this, our final P4. But before we go, here's a little bit of archive footage from our very first P4 assembly video. And yes, that is Richard Hammond and Paul Ross. See ya.